we are going to discuss an important topic, rising global temperatures. We are all aware of the rising land and water temperature. The earth is definitely warming up. But what are the exact numbers? Is the temperature rising rapidly or steadily? Let us see. Also, we will look at the different causes for this temperature rise. Before that, we will understand why climate scientists report temperature changes in anomalies. An anomaly is the amount of departure from a baseline average. Our baseline in this example is 14 degrees Celsius, the average of temperatures from 1951 to 1980. We will refer to this 14 degrees as the baseline. In the below table, we can see that anomaly is the difference between the actual temperature and the baseline average. We will plot these anomalies in the upcoming line graphs. A positive anomaly indicates that the temperature was warmer than the baseline, and a negative suggests that it was cooler. Let us go through an example to understand the importance of anomalies. Suppose we want to compare the temperatures of the city area and the mountain top of a valley. Both actual temperatures will differ, but we can conclude whether both temperatures are above or below the average using anomalies. This is the information we need to track temperature changes. What is the trend of the rising temperatures? Using color, these concentric circles show how the temperature is increasing rapidly. Especially the jump from 2015, which was 1.4 degrees, to 2016, which was 1.60. That is 1.60 degrees above the baseline of 14 degrees Celsius. Okay, global temperatures are definitely increasing. But which season do you think is getting affected the most? Let us use data to understand. This line graph shows winter trends in orange line. We can see prominent peaks in 2007, 2016, and 2020. Let us look at the modeled estimates that different climate factors contribute to the overall temperature. Is it the sun's heat? What does the graph tell us? The graph shows temperature anomalies in gray and the estimated impact of solar radiation on that year's anomaly in green. The green line is well below the gray anomalies, which means that the sun's temperature has had minimal effect on warming the earth. If not solar, is it because of volcanic eruptions? We might feel an inclination to thinking that lava and gases may be significant contributors. But the sulfuric emission increases the reflection of radiation from the sun back into space, and thus cooling the earth. The graph proves that. If none of the natural causes are contributing, it must be because of human factors. Is it deforestation? No, the estimated impact of deforestation is not significant because even though forest area continues to deplete, the rate has declined over the years. Are those tiny aerosol particles responsible? Let us check. Some particles warm the earth, but sulfate particles cool it. The net effect is resulting in cooling the earth as seen in the graph. The mystery still remains unsolved. Surely it must be because of ozone pollution. Let us see what the graph tells us. The ozone layer blocks harmful sunlight and cools the earth. But despite the pollution, which is warming the earth, as per NASA, the net effect is not much. Is it because of greenhouse gases? Oh yes, look at the red line climbing throughout the years. Certain gases in the atmosphere act like glass in a greenhouse. They allow the sunlight to come in but block the heat from escaping into the atmosphere. Check out how greenhouse gas contribution compares with the other causes. This creative story was built using Tableau, a business intelligence tool for visual analytics. Check out more on how to create such exciting stories at techcanvass.com. Thank you.